let's not wait any longer. Let's go over to see what Phil has to say and let him fill us in on all the things that Blizzard are doing with Spring.
Blizzard makes awesome games, and we want to make sure our players around the world have a great experience, not only within the games, but outside of the games as well. For example, whenever new players sign up, we need to capture data and perform validations that vary according to local laws and regulations, age, authentication provider, and even how they're creating their account, whether it's on the web, within a game, or on a mobile device. That experience has to be fast and low friction. And one of the ways we're making the player experience fast is to deploy our services closer to our players in data centers and clouds around the globe. However, inevitably, some of our services need to talk to remote services in other locations, and we get into a challenge that in our world is governed by the laws of physics, and that is latency. So over the years, we've introduced several asynchronous styles to help make our Java services more responsive in the presence of latency and other long-running tasks. We've used callbacks, promises, futures, completable futures, but introducing these styles came with their own challenges. They're not a great fit for complex composition and data manipulation. They don't really handle back pressure, so slowdowns in the middle of a flow are not handled very gracefully. It's hard to determine context within an asynchronous flow whenever you're debugging problems. And it's also difficult to write and maintain common libraries for all the different styles. So we found that replacing those async styles with reactor offers a much more rich, elegant API. The operators offered by Mono and Flux are perfect whenever you're composing many data streams and data manipulations together. For example, during the account creation flow that I mentioned, we pre-assemble a bunch of reactive publishers that describe things like transformations, decisions, validations, default values, and remote operations. Then we later combine all those dynamically to assemble a full stream that represents the full creation flow that applies for a specific use case. Effectively, Reactor provides the building blocks to create and cache streams at assembly time, and then defer I/O until absolutely required at subscription time. In addition to async programming efficiency, we're seeing runtime efficiencies as well. For example, back pressure provided by reactive streams helps our services tolerate latency better, particularly as we move to more and more locations around the world. So back when we decided to start utilizing reactive streams, we recognized we needed to add reactive support to our common libraries that tie our apps into the rest of Blizzard's operational systems. So we've added reactive support to our metrics and our tracing instrumentation to ensure that reactive apps are just as observable as our non-reactive apps. We also made reactive versions of our communication abstractions for RPC, AMQP, and WebSocket traffic. For example, we replaced future and promise-based Netty code with WebFlux and Reactor Netty. We replaced async listener-based RabbitMQ code with Reactor RabbitMQ, and we replaced callback-based RPC code with other reactive clients. We also took the opportunity to migrate from the old deprecated Spring Security OAuth library to the newest Spring Security releases, which provides reactive OAuth support. We even started to use the reactive types as a common API for our cross-cutting libraries so that we don't need variants for each async style. So all these changes let applications be reactive through the whole stack, which really unlocks the power of Reactor. However, we do have some apps where we've only introduced reactive clients without handling inbound traffic reactively. So this has helped developers become familiar with reactive programming before taking a big architectural leap for those apps. And speaking of developers, one of the biggest challenges of getting to production with Reactor is for developers to be able to effectively troubleshoot reactive applications. Generally, we start troubleshooting with metrics and tracing and logging information to kind of narrow down where to investigate. And since we've added reactive support to our observability libraries, we can take advantage of all of our existing monitoring and alerting capabilities. So at this level, reactive apps are no different than our non-reactive apps. Once you get inside the app, however, things change. So reading stack traces is different, debugging is different, and profiling is different. But luckily, there's some tools to help with all this. We use the Reactor debug agent to show assembly traces for exceptions and whenever we're debugging in IntelliJ. So this provides a better context as to where a problem has occurred within a stream. And we use block count and IntelliJ inspections to identify improperly blocking code. And we use async profilers to identify bottlenecks that traditional profilers can't find. So with all this, troubleshooting reactive apps is much easier than other async styles, but still harder than the synchronous style. It's not impossible, it just takes a bit of learning and the right tools. And on that note, we've learned a few other things as we've used Reactor more and more. The first is to only introduce reactive streams where it makes sense. It's not for everything. Target your high throughput workloads, your apps that are already asynchronous, or your apps where you want better back pressure support. Then make sure all the operational features of your applications are all covered. By that, I mean metrics, tracing, communication, security, health checks. The Spring ecosystem actually covers a lot of these concerns with projects in Spring Boot, Spring Security, and Spring Cloud Sleuth. But if you have any additional abstractions or you're using homegrown variants, then you'll need to put some time into supporting the reactive style. And finally, as with any technology, there's definitely an upfront learning curve with reactive programming. So plan for that, read guides, watch these SpringOne presentations, and have knowledge sharing sessions. It takes time, but it's not insurmountable, and it quickly becomes second nature.